this video, I am going to be showing you some strategies for how to find the missing side in a rectilinear shape. So the reason that this is important, because like we discussed before, we need to have all of the lengths on the outside, because those outside lengths help us find the lengths on the inside of the rectangles that we make that then help us find the area. So I'm going to be showing you a couple of different strategies that you can use. The first one here is thinking about how my horizontal lines need to be equal to each other, and then my vertical lines need to be equal to each other. So one strategy I like to use is kind of color coding a little bit. So I'm going to kind of color code all my horizontal line or my vertical lines here. So here are all of my lines that are parallel. And I need to notice, okay, this is my longest one, and these are kind of broken up. These two need to equal my longer one. Or this is again an example of opposite sides are equal. So 4 and 3 is equal to 7, and that is true. I then can use that strategy to help me find this missing number here. So I'm going to highlight my horizontal lines here. And again, opposites are equal, so these two opposites have to equal that one. So if I add 5 plus 3, that would get me 8. And then I can now work on the inside of my rectilinear shape, breaking it apart and finding the area. So that is one strategy that you can use, is thinking about vertical lines need to equal each other and horizontal lines need to equal each other. The next strategy that I'm going to talk to you about is kind of similar. Here I'm trying to find this length. This length, remember in rectangles, opposite sides are equal, so this length would be equal to this length if it existed. It doesn't exist, it's chopped off here, but if it existed, this side would be equal to this. So now I can use what I know about rectangles to think that if this existed, this would be 3 because opposite sides are equal. So if this was 3, then these together would make 8. This whole thing would be 8, which then this 8 means that the opposite is 8. So again, I kind of just extended it and pretended that this was just a plain old rectangle here. And I used what I know about opposites. So that is a second strategy that you can use. This is a little bit trickier because you have to be using something that doesn't exist in your shape. Whereas this is these things are already there, and I just have to remember that my two shorter horizontals equal my longer horizontal. My two shorter verticals should equal my longer vertical. And then here's going to be my third strategy. So my third strategy here is going to be, I can break apart on the inside to help me find the outside, which can be a little tricky because typically we work from the outside in. But if I'm missing something on the outside, I can see if I can use something from the inside and work out. So let's go ahead and break this apart now. And then I can use what I know about opposite sides to find this. And then this again is me pretending that this is actually a side. That means this whole side would be equal to this whole side. So let me find the length of this whole side. This whole side is this small part plus this small part put together. So 3 plus 5 would equal this whole side. So 3 plus 5 gives me 8 on the inside, 8 here, or 8 here, because opposites are equal. So these are 3 strategies that you can use to find a missing side. Again, I would say that these are a little bit trickier because you're having to either work from the inside out. Here you're having to use something that really doesn't exist in your shape. You're kind of having to visualize it being a rectangle. I really like this one because I'm thinking about vertical lines being equal and horizontal lines being equal. And now that you have all of the outsides, then you can go ahead and work on the inside. So just as a reminder, I could break this apart. and then I can use my safe sides that haven't been touched. So this 8, it was broken apart, so I'm not going to work with that one. This 3 here was made longer, so I'm not going to work with that one. So I'm going to use these. These are safe. Here, this 4 stayed the same, so it's 4 on the inside, which means this opposite is 4. This 3 here stayed the same, so it's 3 on the inside, and the opposite is 3, which means the area is 3 times 4, 12 square units there. Now let me go here to some safe sides to help me. Again, this 8 was broken up, so that's not safe. I'm not going to use that right now. This 3 was made longer, so I'm not going to use that one. I'm going to use this 7 and 5. This 5 stayed the way it was the whole time, so I'm going to use this, and then I'm going to make the opposite side. This 7 right there, so I'm going to make that, and then I'm going to use multiplication of 7 times 5 is 35. And then I'm going to add these two smaller areas together to find the total area. So the total area is 47 square units. And I could do that same thing here. I could do 8 times 4, and I could do 5 times 3. So here we have 15, and here we have 32. So 32 plus 15 is 47 square units. So again, use those strategies first to help you find the missing sides, and then follow those steps of working from the outside in to find the total area.